leadership provided by our Vice Chancellor. Therefore, it is with great pleasure that I now invite Rear Admiral Jagath Ranasinghe, the Vice Chancellor of General Sir John Kothawala Defence University, to formally welcome the gathering. Over to you, sir.
Honorable Secretary to the Ministry of Defence, President Council, Mr. Kapila Vaidyaratna, Chancellor of KDU, Admiral Das Santagiri, Keynote Speaker, Professor Mohan Manoj Singh, Guest Speaker, Dr. Salat D. Gunapala, Commander of the Sri Lanka Navy, and the Chief of Staff of Air Force and Army, members of the Board of Management of KDU, Chairman UGC, Your Excellencies of the Diplomatic Corps, conference participants of friendly nations, Vice Chancellor of Morato University, former Vice Chancellors and Commandants of KDU, senior officers of the Tri-Forces and also the police, academic and administrative staff of KDU, distinguished ladies and gentlemen. Let me very warmly welcome our Chief Guest, Honorable Secretary to the Ministry of Defence, Mr. Kapila Vaidyaratna, who very kindly accepted our invitation to grace this occasion of the inauguration of the 11th International Research Conference of General Sir John Kothawala Defence University, along with all the other dignitaries, both local and foreign, who have honored us by being here to witness this occasion. Ladies and gentlemen, today, in addition to being the Defence University in Sri Lanka, with 9 well-established academic faculties, we have reached higher planes in the overall university education system of the country. We have shown over the last few decades that we achieved persistent success in all our undertakings, initiated with patriotic motives. And it is our belief that the blessing of our benefactor, the late General Sir John Lionel Kothawala, have always been the reason for such success. Despite being a defence university today, we proudly shoulder a significant share of the burden of providing high-quality tertiary education for deserving youths in Sri Lanka by allowing civilian day scholars to follow our degree programs, which is, as you would agree, a great national service and a helping hand to the university education system of Sri Lanka. Ladies and gentlemen, quality education is the nerve center of nation, and if a country imparts substandard education to its youths, surely that entails self-destruction. So quality education is a must in the contemporary world. With substandard education, the buildings and bridges designed by architects and built by civil engineers may collapse. Doctors will not be able to properly diagnose diseases to cure them. Nurses will deviate from the best practices and value of their profession. So it is the utmost responsibility of the nation and its educational institutions to ensure the availability of highest possible standards of education for the youth. So the prime concern of our university is to always provide the highest quality educational opportunities possible to our student population and to motivate them to be engaged in research and innovation. So quality education is the overarching theme of all our endeavors. Ladies and gentlemen, in the modern times, it is not advisable to compartmentalize ourselves into specific fields. On the contrary, it has become essential to establish multidisciplinary collaborations among people engaged in divergent fields. Hence, establishing relationships with experts in different fields would help emerge new innovations to bridge gaps and achieve professional excellence, which is the challenge of the 21st century. This explains the validity of the theme of our 11th International Research Conference, Securing Professional Excellence Through Collaboration. Ladies and gentlemen, professional excellence through collaboration is part and parcel of the unique culture of KDU. Therefore, by conducting this conference on the selected theme and its sub-theme under different faculties, we bring professionals and researchers of different disciplines to a common platform to disseminate their valuable research findings. Further, we establish and strengthen partnerships and collaborations across national and international researchers, and we encourage our researchers to excel in advanced research for the development of a secure nation through professional integration. KDU IRC is an ideal opportunity for the academia and professionals to meet, discuss, exchange views in an academic environment. What is special about our conference is that it is enriched with the participation of many local and foreign academics in varied disciplines, along with individuals from all three armed services and police. Therefore, this is the only conference in Sri Lanka that brings together civilian professionals and their military counterparts. I extend a warm invitation to the local and foreign students, academics and professionals present here today to present their research findings, engage with other researchers in your field of study, have fruitful discussions, and build lifelong friendships with one another for mutual benefits. Ladies and gentlemen, we have noted that our research conference receives increasingly large number of submissions each year, and it is heartening to state that in this year, the conference secretariat received nearly 600 research papers, out of which 350 were selected for oral and poster presentations through a double-blind paper reviewing process. The double-blind peer reviewing process. So let us look forward to participating in highly fruitful plenary sessions in which eminent researchers and professionals in each field will provide insights on selected sub-themes and in technical sessions that will be adorned by high-quality research presentations. I conclude my speech emphasizing that we are a nation from a small country in the world, but our history proves that we are a people with strong determination, with great attitudes. With sound practical education, we can definitely maintain these great qualities of our nation in the years to come. I wish everyone would have an inspiring and unforgettable time at KDU during this two-day conference. Thank you very much.
Ladies and gentlemen, we are indeed thankful for the presence of our chief guest, Mr. Kapila Vaidyaratna, President's Counselor and Secretary to the Ministry of Defence. Mr. Vaidyaratna is a star-studded alumni of St. Thomas's College, Mount Lavinia, who received multiple awards during his school career, including the prestigious Victoria Gold Medal for his outstanding performance in both academics and sports. Following his secondary education, he obtained a bachelor's degree in arts, with specialization in economics, and master's degrees in international relations from the University of Colombo. Mr. Vaidyaratna also pursued legal studies at Sri Lanka Law College and was enrolled as an attorney of the Supreme Court of Sri Lanka in the year 1982. In the year 1983, Mr. Vaidyaratna joined the Attorney General's Department as a state counsel and was promoted to the position of Senior State Counsel in the year 1994. He was elevated to the position of Deputy Solicitor General in the year 2005 and an Additional Solicitor General in the year 2014. During his career at the Attorney General's Department, Mr. Vaidyaratna was involved in a number of complex and controversial criminal prosecutions in the country and also headed the Criminal Division of the Attorney General's Department. His professional affiliations extend to institutions such as the Medico-Legal Society and the Asia Crime Prevention Foundation of Sri Lanka. Other notable milestones in his career as a legal professional include serving as a prosecutor and a trial attorney at the United Nations International Criminal Tribunal for former Yugoslavia from the year 1998 to 2003. He has acted as a resource person for the International Labour Organization, the International Organization for Migration in Sri Lanka, and Australia-Sri Lanka Mutual Legal Assistance Program. Mr. Aidaragna was appointed as the President's Council of the Democratic Socialist Republic of Sri Lanka in the year 2015 for his unblemished service record and his noteworthy contribution to the legal profession of Sri Lanka. Mr. Kapila Aidaragna was appointed to his current office as the Secretary to the Ministry of Defence on 4th July 2017 by His Excellency the President and the Commander-in-Chief of the Armed Forces of the country. Sir, it is with great pleasure that I now invite you to address the gathering.
Good morning, everyone. Chancellor, the Vice Chancellor, Secretaries to the Ministries, Commander, Sri Lanka Navy, Chief of Staff, the Army, Dapat Fernando, and the Air Force, Subhankar Das, Your Excellencies of the Diplomatic Corps, international organization scholars, and other distinguished invitees. It is my privilege and honor to be present here as the chief guest and of the inauguration ceremony of the 11th International Research Conference organized by the Kotalabala Defence University, which I happen to be the ex-official chairman of its board of members of the management. Let me first express my thanks to the Vice Chancellor and the conference organizers for inviting me as the chief guest of this very significant event of the university. Ladies and gentlemen, as the Defence Secretary and also the Chairman of the Board of Management, I'm aware of the outstanding role played by the Kotalabala Defence University in the tertiary education landscape of Sri Lanka today. With the donation of this beautiful estate, along with the Kandavilla mentioned by the late General Sir John Lionel Kotalabala, the third Prime Minister of Sri Lanka. The KDU was founded in the 1980s as the only tri-service academy in the country to provide much needed university education to the officers of the three services. Since then, the KDU has come a long way over the last several decades, reaching heights that may not have been dreamt at its inception. Over the last 30 years, the KDU has produced thousands of graduate officers of very high caliber to lead the Army, the Navy, and the Air Force as a highly disciplined and a professional forces. In most recent times, with its expansion to provide its higher education opportunities to deserving civilian students. The KDU has earned a name within the outside the country as a university that provides high quality tertiary education in diverse fields in a disciplined environment. In most recent times, today, with 9 academic faculties, the Southern Campus and the recently established the University Hospital, the KDU has come to the forefront with the determination to serve the nation in the best possible way. Therefore, let me congratulate the Vice Chancellor and his able staff for the tremendous job, the excellent job done by them. And also let me also take this opportunity to salute the pioneers of the university, especially the late General Sir John Kothalavala and Deshamania, late General Dennis Pereira. And let me not forget the political leadership of His Excellency, the former President, Jaya Jayawardena, for the foresight to establish this university far back in 1980. Ladies and gentlemen, the 11th International Research Conference that we are inaugurating today is a testimony for the significant role played by the KDU in the field of the higher education of Sri Lanka. As you are aware, it is not at all an easy task to successfully organize an annual conference of this magnitude consecutively for 11 years. This itself indicates the strong commitment, the responsibility of Kothalavala Defence University to provide opportunities for the all-important task of knowledge creation and dissemination. As you have already heard, and what I gathered from the Vice Chancellor, every year the number of research papers submitted for this conference is on the increase. It is heartening to note that thousands of researchers from all over the country as well as the world consider this conference an appropriate platform to present their papers. Therefore, in my capacity as the Chairman of the Board of Management of KDU, I too share with the KDU the pride of the leading role played by this Defence University in popularizing research, which I believe is essential, a key aspect in the nation's growth. Ladies and gentlemen, the conference theme, the professional excellence for collaboration, is timely, particularly for countries like ours, in our quest for appropriate development strategies in the face of new global challenges. We do need meaningful collaborations across diverse professional bodies, and we cannot be completely looking after our own professional interests in isolated compartments. So time has come for all professionals to unite in sharing the burden of developing our nations economically, socially, and culturally, so that the future generations will have a safer world to live. I believe it is our professional responsibility, whether we are scientists, doctors, engineers, lawyers, academics, administrators, military professionals, or any others. Irrespective of such labels of distinction, we need to find opportunities for innovative collaborations to forge ahead. And as such initiatives, we all must reach excellence in our own professional domain. And it is in this respect that universities and higher educational institutions come to play an important role. Ladies and gentlemen, it is my belief in this respect, General Sir John Kotalawala Defence University is discharging its duty to the nation in a commendable manner. So let me conclude without taking much of your precious time, as there are two eminent, internationally recognized Sri Lankan intellectuals to deliver keynote addresses at the conference. Let me once again thank the Vice Chancellor, the organizers for inviting me as the chief guest this morning. And let me also take and congratulate them for organizing a conference of this nature on a very timely and an important theme. Finally, let me wish the two-day conference, both national and international participants, for a highly productive conference with the intellectual stimulating deliberations. Thank you very much.
Thank you, sir. I would like to request you to remain on stage for a moment. We are truly grateful for your presence, and to express our appreciation, I would like to invite our Vice Chancellor to present a memento to the chief guest. Thank you, sir. Ladies and gentlemen, we are fortunate to have here with us today as the keynote speaker of KDU IRC 2018, a brilliant interdisciplinary scholar whose prowess covers a wide array of disciplines and who is, most importantly, a Nobel laureate. This introductory video is a homage to his invaluable contribution.
Vanakkam, greetings. Good morning to everybody. It's a very distinguished audience. Vice Chancellor, Secretary, Service Commanders, distinguished guests, Excellencies, and of course, fellow academics. I'm going to talk to you very briefly about the Sri Lanka Sustainable Vision and how we can achieve security, peace, and prosperity through what I call the balanced, inclusive green growth path. I have a lot of slides to show, so I'm going to click through many of them, but you can see later. I put it up on a website. I don't have time to show all of these slides. So it's a privilege really to be talking to the cream of the security community and distinguished guests. I would like to emphasize that we are looking for win-win solutions for people, planet, and prosperity for the entire globe. And there is no excuse for delay, as I will show you. For example, last month I was with US President Obama at the Climate Leadership Summit in Portugal. There were 3,500 political and business leaders in that room, who pledged to take action. And it is up to us in Sri Lanka also to move on the path to sustainability. Just to show what we are doing, also last month I presented a report called Sustainable Sri Lanka Vision and Strategic Path to His Excellency the President. It's a one-year effort prepared, I'm proud to say, by all Sri Lankan experts. And this is our contribution to the United Nations Sustainable Development Goals. And we are one of the first countries we are leading in that respect. As you know, the Sustainable Development Goals is a key measuring framework which will show us how we are making progress. Now, let me talk very briefly about the major issues that we face that threaten global security and which also are a threat to our security. There is poverty and inequality, there are resource shortages, shocks to the financial sector, also disasters, conflicts, and unfortunately, weak leadership at the global level. Climate change is, of course, the ultimate threat multiplier because it makes all the other problems worse. If you look at the bottom of the slide, you see the problem. You see we are all 7 billion people on the planet are stakeholders, but we are very disunited in the way we address these problems. It's very uncoordinated, very peaceful. We need a very robust, integrated and comprehensive strategy. I think what institutions like the KDU have to provide the solutions, and when I see the young faces in the room, I feel a lot of hope that we also, although we are small in Sri Lanka, can make a contribution to the peace, prosperity and security of this planet. I'm going to click through this and show you very briefly one of the nexus issues, which is a combination of circumstances. There is a concept called ecological footprint of humanity, which tells us how much of the planet's resources we are using in total. In 2012, we were using 1.5 times the equivalent of what the Earth can sustainably produce. And by 2030, if we continue our present pattern of development, we will need 2 planets. And we know that we have only 1 planet. Sri Lanka is also exceeding its own ecological limits because we are chopping down the forest, polluting the water and so on. Now, we have another question here, the question of overconsumption, because if you look at who is doing the consumption, it's the richest people on the planet, the top 20% who are consuming 85% of the resources, which is 60 times more than the poorest. Just imagine that the 8 richest people in 2016 had more wealth than half the world's population, 3.5 billion. So that is the extent of inequality, which is a major issue. Now, if you put those two together, you look at the bottom panel, you see that the rich are already using more than 1 planet worth. So where are the resources to help the poor? That is why we have 70 years of unmet goals and broken promises, starting from the 1947 UN Universal Declaration of Human Rights, which had all the 17 sustainable development goals that we have today when they are 70 years ago. And we are repeating them today with the SDG. There are growing inequalities of wealth and income, which I just showed you. Wars and disasters have created refugees, 65 million people last year. The financial sector, which created the 2008 asset crisis, has gone back to its practices, in my view. So we are probably going into another global recession, not too long in the future. And something for you to think about, we are moving from a unipolar to a multipolar world order. Asia has a very key role in this. And this is the friend. Sri Lanka has a dynamic non-aligned strategy, friend of all, enemy of none, which is something that the president emphasized to me very much. So the multipolar world order will be hopefully much more dependent on soft economic power rather than military power. And you have many poles of influence in the world. And as we move to that, there will be disturbances. But we, Sri Lanka, as I show you later, have a very key geostrategic position, and we can play a role in this. Let me now talk very briefly about climate change. That is, it has many facets. There is a huge report like this, which I helped to write, which describes all of the problems of global warming. But there are two key facts which are the most important. One is that the poor countries and the poorer groups will suffer the most. This is manifestly unfair because the poor countries and the poorer people had the least to do with creating the problem. The problem was mainly created by the rich countries, but the poor will suffer. The second important point at the bottom of the figure is that if we follow this balanced, inclusive green growth path and make development more sustainable, we can meet the challenge of climate change, as well as all the other problems like poverty and so on. I'm going to click through this and come to the lessons of history, which very briefly is the following, that we have had many civilizations which have lasted thousands of years. The Han civilization in China, the Maurya Gupta empires in India, Mesopotamia, the Roman Empire. But they have all collapsed eventually because of environmental and social factors. Okay. Mainly overconsumption of resources, which we are doing now, and division, social divisions between rich elites and poor masses. So these are very important aspects. We can learn a lot from the past history. If you take, for example, the hydraulic systems in Sri Lanka, we had a wonderful sustainable vision. For example, we believe that land belongs to the people and all living things, while the ruler is only the guardian of the land. And King Parakramabahu said not even a drop of rainwater should flow into the ocean without serving man. If you look at the old dam anechots, you will see that they were positioned exactly where the modern instruments tell us where they should be. They were eco-friendly. And we had systems like the Velvidana system, social systems controlling the flow of water, which was extremely sustainable. So we have to be very much aware of these environmental and socio-economic factors, the scarcity of resources, and inequality and conflicts, which can affect also our present civilization. It could lead to some process of barbarization, where you have unrestrained market forces combining with various problems like poverty, inequality, climate change, to lead to a total breakdown of the planetary system. And if you see, for example, the mass movement of refugees and other people, which is more and more difficult to control, it is really a threat to global security in the future. So we now come to the last hope for mankind, in a sense, in this era, which is the 2015 Sustainable Development Goals and the UN 2030 agenda. Let me click through this and talk to you very briefly about how we can solve these problems. And this is a framework called Sustainomics, which I presented in 1992, more than 25 years ago, at the Rio Earth Summit. Balanced, inclusive, green growth path. If you analyze the words, inclusive means social, green means environment, growth means economy, the three elements of the sustainable development triangle. And one of the core concepts that is extremely important here is making development more sustainable. It's a call for empowerment and action. It basically says that sustainable development may be very mysterious. It's like a mountain peak covered with clouds, but we don't need to be discouraged. We take one step at a time and climb uphill. Eventually we will reach that. And the important thing here is that you and I, individuals, can make a difference. We don't wait for presidents and prime ministers and others to tell us what to do. Many of us know what we need to do. We can say, when we leave this room, we switch off the lights. We can turn off a tap. We can plant a tree. Many things we can do that are extremely sustainable. Empowerment is extremely important. At the company level, we have corporate social responsibility and many other things. At the city level, we can practice sustainable cities. And we come to the second core concept, which is essentially what I told you before, that we need a prosperous economy, because especially with many millions of poor people in the world, we need to bring them out of poverty. But we also need to look at the environmental side, that in the process of growth, we don't want to destroy the environment, and we need the social side, which is the most neglected part, that unless we have the social harmony, none of the other things will be helpful. And I think the KDU and my own institution, mine, have a very key role to play, and I would emphasize especially the social capital. Because the built capital, this building, the roads, the cars, and everything we use, we can understand. We can understand nature quite well, the forests, the lakes, the air we breathe. But the social capital, the human and cultural capital, we have neglected, and we had a 30-year war which eroded a lot of our social capital. This is the glue that binds society together, and I think KDU has a major role to play in that. Just to remind you of the 2004 tsunami in Sri Lanka, which is a shining example of social capital working. We were in the middle of a civil war, we were a poor country, 1 in every 500 people were affected by the tsunami. Right? But every country in the other countries thought our society would collapse. But we rallied. People went out onto the beaches voluntarily, helped other people, cleared the bodies. There was social capital at work. If you look the following year in Hurricane Katrina in 2005, in one city in New Orleans, what happened? There was no social capital. There was complete breakdown of law and order, looting, raping, and other things going on. It was a shocking thing because it's a very wealthy country in one city. So I have written a paper on this, which is very much a classic, saying social capital is not necessarily the property of the rich. In poor countries, we have that. We have it in Sri Lanka, we must build it, and we must continue to do that. I must also tell you very briefly that we need to transcend boundaries within our own minds. Also, this is for innovation, and that is what the KDU has to do. Values are extremely important. We have to replace unsustainable values with more ethical values. We need to think in terms of multidisciplinary issues. We need to think in terms of the whole planet, spatially, not just our own backyard. We have to think in terms of long time spans, decades or centuries. And as military practitioners, I'm sure you understand that long-range plan, not just today or tomorrow. And we need to work with all stakeholders. That is government, not only government, but also civil society and business. Just to emphasize the question of social values, it's unethical social values that actually drive our society together, like injustice, violence, elitism, greed, and selfishness. That has created a state of what I call economic, not development, maldevelopment. We are growing based on debt, poverty, inequality, and so on, which is not a very healthy way to go. And that has created what is called the environmental debt. We are overusing our planetary resources and also causing climate change. When we deplete our natural resources, then there is more conflict. So you have unethical social values. That is a vicious cycle. If you look at the pattern of wars today, there are no wars on weapons of mass destruction. The wars are all for resources, for oil, for water, and for land. Okay? Everything else is a smoke screen. So this cycle has to be broken. And we have to transcend disciplines to do that. I think the Secretary made this point very clearly, that we want to think in terms of multidisciplinary terms. And we need to bring civil society and business to work with government, to push them to strengthen democratic space and provide good governance, and so on. Let me just briefly tell you that climate change is in a precarious situation today. The second top, we have 280 parts per million as the main, the indicator of the carbon dioxide level in the atmosphere, okay? That was the safe level 100 years ago or more. Today it's over 400. So we are exceeding the safe level of carbon dioxide, and what will happen is that we will have global warming, we will have more rainfall in wet areas, so you have more floods and landslides. We will have more droughts in dry areas, so more deserts, and we will have storms, cyclones, and other things, in addition to sea level rise and overall temperature increase. Okay, so the economic damage over the last 50 years has been rising, and it's going to continue to rise. I'm going to click through this just to remind you that unfortunately we know what we need to do to survive climate change, especially to protect the vulnerable people, the poor, children, and elderly. Some parts of the world, like small islands like Maldives and other, which will be completely submerged, and particular sectors and systems like agriculture, coral reefs, and so on. But unfortunately, we are not doing those things. There is a process called mitigation, which is to reduce the amount of carbon dioxide emissions, which was mainly the responsibility of the rich countries, who are the main emitters on the planet. But from 1992 onwards, the Kyoto Protocol in 1997, we have been sliding back. Every time we have an agreement, but the promises are not kept. Today, we have the Paris Accords of 2015, which our president signed also. But again, the US has refused. We are facing something like more than 3 degrees temperature rise by 2100 at the very bottom of the paper thing. And unfortunately, 3 degrees is very dangerous. According to scientific thinking, we should not have more than 2 degrees temperature rise. If you have more than 2 degrees, the amount of damage to ecosystems, to agricultural production, to water resources, in terms of storms and hurricanes, extreme events, will be very serious. So 3 degrees is unacceptable, and in spite of the Paris agreements, that's where we are headed at the present time. So we have to do something about that. Let me just now tell you what exactly is this balanced, inclusive, green growth part, right? If you look at climate, environment on the vertical axis and development, which is GNP per capita on the horizontal axis, you see that black curve. If you're a poor country, you're at point A, which means you're poor, but you're also not damaging the environment very much because you're not consuming much. If you're a rich country, you're at point C, you are rich, but you are above the safe limit in terms of consumption. You are emitting a lot of carbon. Most countries are in the middle, okay, the point B, including Sri Lanka. So an important aspect is for the rich countries to reduce their emissions of carbon, to reduce their consumption, right? And it can be done without going into poverty. They can have a very good quality of life, but they can reduce their consumption. We have the technology to do that. For us in the middle, we have a different path. This is the balance, this is the green growth path, which says that we can reach the same point E, prosperity, sustainable, but we don't have to follow the same wasteful curve of the rich countries. Why? Because there are not enough resources, as I said, on the planet to support 7 billion people in the same lifestyle as, say, North America. It's too wasteful. But we have a technologically advanced path, a leapfrog, which we can use. And then we come to the, what I call the BIGG path. So because in addition to environmentally and resource efficient green path, we have to make it an inclusive path. Because it is not enough to grow rich and be green, but to have inequality. Okay, the planet is not only for the rich. So inclusive means that we have to bring in social into the green growth. And that is why it's called balanced inclusive green growth. Just to show you, the panel on the top shows in terms of sustainable consumption. A rich family, this is consumption for a week. Now they can consume the same amount of food but with less packaging, less other things, and reduce the consumption. Same quality of life but reduce use of resources. The people at the bottom, poor family, they have to come out of poverty. Otherwise they will not survive. So they have to follow the tunnel, the balanced inclusive green growth path. So these are two different paths for two different people. I'll talk to you very briefly about sustainable production. I have worked with some of the biggest companies in the world, the multinationals, the biggest chemical supermarkets, oil and gas, plantations, biotech, mining, all of these. Two key points talking to the CEOs, the boards of these companies. Sustainability and triple bottom line. That is finance and economic, environmental, and then the social. Those three have become much more important. It's not only a question of profits anymore. Okay? The second one is that resource use efficiency is a very good starting point. What do we mean? If you are producing shoes, if you can produce the shoes using less leather, less energy, and less water, this is win-win. Because you are reducing the burden on the environment, but you're also reducing your cost. So this is very attractive. And now we have technologies which are win-win, right? So this resource efficiency, I've clicked through this because I don't have time, but there are many technologies which we have applied, for example, to the case of a garment factory in Sri Lanka, the mass holdings, which show you how resource efficiency works. And I'll just summarize for you very quickly the analysis. We have looked at how carbon and energy are used in the life cycle of the product, from the raw material to manufacturing, to distribution, to use and disposal. And the main carbon emissions of a garment comes from the raw material, not from manufacturing or anything else. So what is the lesson for us here? If you want to reduce emissions in carbon, you are not going to tinker with the manufacturing process. You are going to talk to your procurement officer. The procurement officer must buy the raw materials from the sources which use the least amount of carbon. So it's not an engineering problem. It's a production, procurement problem. So this kind of analysis tells you where the hot spot is. For energy, the hotspot is in manufacturing and distribution and in final end use. Why? End use because people have to wash the garment, and that is very energy because of hot water. So these are methods of improving the production process. And let me just tell you that what we are planning here is to have sustainable consumers and sustainable producers working together. Because what you see in advertising today in the TV is mainly very unsustainable. It tells you to buy more, and it tells you to buy very unsustainable products. We have to break that cycle. And eventually, if we get these sustainable consumers and sustainable producers working together, we can eventually have a sustainable society and use modern tools. Traditional markets for old can have organic markets and other things, okay, which you actually go and buy the stuff. But for young people, it's online markets. I am supporting a startup company which has a huge sustainable online market. Most young people who are in their 20s do not want to visit a shop. They go to the computer and shop online. Right? So you have to have the tool to do the right thing. And through these sustainable markets, you can build a sustainable society. Let me come to the last part of my presentation, that is showing global leadership. In the Sustainable Sri Lanka vision, we have said we hope to have a thriving economy. We don't want to be poor. Being green and inclusive does not mean poor. We want to be prosperous, high quality of life, and advanced, stable economy. But it is green. It builds on our traditional respect for nature and resource use efficiency, and it is an inclusive society. This is also the vision of His Excellency the President, with reconciliation, harmony, and social justice, following the balanced, inclusive green growth path. And let me just tell you also about the report. I brought a copy with me, but it is also available on the web. It is not a political manifesto. This is a document up to 2030. It builds on existing documents. It's not reinventing the wheel. It is a strategic document because there are other departments of government who are doing the detailed plans. We have given a strategic report. It is a unified report, and we believe that we have to transform values, mindsets, behaviors, institutionals, tools, and technologies. I think the KDU has a very critical role to play in that transformation. And I give full credit to His Excellency the President, who asked the Sri Lankan team of scientists to produce this report. And we, in spite of different points of view by different experts, we eventually managed to get a consensus. Okay? There is the economy, environment, and society are very well integrated, three main elements. But we have also many sectors like agriculture, education, energy, health, and so on, which are also integrated into the three main elements: economic, environmental, social. And we have also cross-cutting issues. And if you look in the cross-cutting issues, you have things like values, gender, international relations, security, and peace. So all of these are integrated into the report. This is one of the failings of Sri Lanka, that every department of government is pursuing its, in a sense, an isolated agenda. And it is up to people like you, thought leaders, who can contribute to bring this integration about. Let me just finish by saying we need to harmonize the economic, social, and environmental to build a democratic space for Sri Lanka. We need to work with business, civil society, and government, all working together. Let me just end by reminding you that the situation in Sri Lanka has to be improved quite substantially, because inequality has become much worse in the last 2 decades, right? So although GDP is growing, it's not reaching down, and that is a very important aspect. Spatially also, the Western province and so on are much better off than, for example, the dry zone. We are not investing enough in health. We are not investing enough in education. It's rather low as a percentage of GDP. We have also other things. Okay, for example, the Belt and Road Initiative of the Chinese government is a very important part strategically for us. If we want to be an Indian Ocean hub, we have to understand, if you look at the bottom here, that we are right in the middle of the maritime BRI, right? So we need to be friend of everybody and enemy of none. And we have two major ports, Hambantota and Colombo, right in the middle. So Sri Lanka's geostrategic position allows us to play a very key role, and the investments in the Belt and Road Initiative will also help us to bring that about. But we have an important balancing act to play. And I think the Foreign Ministry and the security forces of this establishment of this country have a very important role in maintaining that balance and bringing prosperity to Sri Lanka. So for defense services, you have to be good professionals. First, as professionals, you have to be the best. But you have to also understand the economic, social, and environmental dimensions of your job. Okay? And you have to broaden your perspective to bring those aspects in. So this is a difficult thing. We are asking our graduates and others to narrowly focus on their expertise and to be the best in the world. But then you're also saying, no, but you have to have a broader perspective also. That is a tough task. But that is the challenge that is facing you in terms of multidisciplinarity. I think you can do much for building the nation and one flag, protecting the democratic space. And we have to understand the concept of national identity. We are all Sri Lankans. You have a role in disasters. This is a peacetime role, going from conflict to reconciliation, and for education and training, raising the standards of national conduct, especially among young people. Be an example. Service to the nation, honesty, integrity, respect for nature, discipline, leadership. All of these values have to be rebuilt in major parts of the society. And the last major frontier we have, the overlooked potential, is the marine area. I won't go through all these numbers, but more than 60% of global GNP is generated in coastal areas of the planet. If you look, all the bigger cities are along the coast. Fisheries and aquaculture generate almost 1 billion jobs. In Sri Lanka, 1/3 or more of the population live in coastal areas. It contributes 40% of GDP and so on. So if you look at the major issues that we have climate change, which will affect the marine resources. We have mega projects, ports, cities, and so on. Tourism, shipping, discharges from ships, agriculture and urban pollution, and individual waste, plastics, human waste. They are going to affect coral reefs, mangroves, the beaches, fishing, marine mammals, and national security. This is the last real challenge. And again, I put it to the KDU and its graduates and the students that this is where you can make a major contribution. My own institute is very heavily engaged, and I welcome your participation. Last but not least, we have to watch out for potential surprises, because we will continue, as I said at the beginning, to have economic crises. So this will always happen. So we have to be secure. We have to have there will be environmental crises, including natural disasters and other things. We will have social unrest. Okay? Ratu Paswala incident, which happened some years ago, is not necessarily an isolated incident. There are resource scarcities and pollution and other things in this small, highly populated island are something we really have to look after. And I think the discipline and the commitment shown by the defense establishment and the defense forces will play a very critical role in managing this. And finally, last but not least, climate change is a huge threat multiplier because it makes all the other problems worse. That we cannot control, but we can manage. So my final message for you is that we face multiple problems, but we know how to address the problems. Unfortunately, we need to move. We have to go on this balanced, inclusive green road path. The Indian Ocean is a key area where we can do this. We need also bottom-up leadership and innovation. We don't have to wait for global leaders to tell us what to do. And I think KDU and Sri Lanka Defence Services can lead the way to peace and prosperity in the 21st century global civilization. And I also have faith in the youth of today, many of whom are in the room. I finish with this ancient Pali blessing, which is in the preamble to our constitution. May the rains come in time, which is environment. May the harvest be bountiful, which is economy. May the people be happy and contented. May the king be righteous. That is society. So many hundreds of years ago, our ancestors knew about the Sustainable Development Triangle. We are just rediscovering it today. My institute is doing research in many of these areas, and I welcome you to contact me if you want to. Stuti Nandri, thank you very much.
Thank you very much, sir, for your thought-provoking words. I think you made it abundantly clear that individual action and commitment matters when ensuring the betterment of our collective future. Ladies and gentlemen, today we are fortunate to have the chance to listen to another eminent innovator, researcher, and a world-class scientist. This video is an introduction to that outstanding personality.
An innovator with a vision, a researcher with a mission, a scientist with a passion. One of the most revered Sri Lankan scientists in today's world. Born and raised in Sri Lanka, Dr. Sarath Gunapala is well known today as one of the leading scientists in the modern days. He received his primary and secondary education from Nalanda College, Colombo. Dr. Gunapala received his bachelor's in physics with honors from the University of Colombo, Sri Lanka in 1979 and master's in physics, followed by his PhD in physics from the University of Pittsburgh in 1986. He joined NASA's Jet Propulsion Laboratory in Pasadena, California in 1992, where he later on served as the senior research scientist. Dr. Gunapala was actively involved in inventing and developing instruments for the use of space exploration, medical research, and more. He was the principal investigator of a major Department of Defense-funded infrared detector program at JPL. This also included an industry consortium formed between JPL and several major US industries. First demonstration of the 640 into 512 pixel portable LWIR QWIP camera was done by him in 2001. One particular application of this camera is breast tumor imaging system BioScan, developed by Omnicorda LLG. BioScan is based on portable QWIP technology. He initiated the antimonide superlattice detector development project at JPL in 2003, which led to the development of the complementary barrier infrared detector for long wavelength infrared applications. Later, in 2010, the antimonide superlattice detector development project led to the breakthrough in high operating temperature barrier infrared detector development. He succeeded in developing and delivering 9-band megapixel QWIP FPA sensitive in the 7.5 to 12 micrometer spectral range to the hyperspectral thermal emission spectrometer funded by NASA's Instrumental Incubator Program in 2011, and also developed an infrared search and track and a dual-band missile identification system for the Airborne Laser Program funded by the Missile Defense Agency in 2009. He has earned a number of awards and honors including SPIE George Gerard Award for Development in Quantum Structures Based Infrared Detector and Focal Plane Array Technologies for Aerospace Applications August 2018. MSS Herschel Award for Development of High Operating Temperature Barrier Infrared Detector. Military Sensing Symposia, March 2018. Sri Lanka Ranjana Presidential Honours, Sri Lanka, March 2017. Fellow NASA Jet Propulsion Laboratory, 2014. Outstanding Leadership Medal, 2014. Kirti Sri Feliciation, Nalanda College, Colombo, Sri Lanka. The distinguished Sri Lankan scientist, Dr. Sarath Gunapala, is here today with us. We may now have the privilege of listening to him.
Good morning, Honorable Chief Guest, Chancellor, Vice Chancellor, and the Deputy Vice Chancellor of KDU, organizers of the conference, distinguished guests. It's my pleasure to be here today, and so I'm going to talk about the exploration and solar system and beyond, exploration of our solar system and beyond. In next 30 minutes or so, I'll have small stories to make it memorable, and I hope you will enjoy the next 30 minutes. I'm Sarath Gunapala. I work in NASA Jet Propulsion Laboratory. Our main business from NASA is the exploration of solar system and beyond using robotic spacecraft. So if you hear anything in the news going to Mars, rovers, or satellite around Jupiter, Saturn, or beyond solar system, that's what we do. So we design, build, we send them to Cape Canaveral. After launching, 7 minutes after launching, we take control of it, and we have a deeper space network, and so we can listen to our satellites even beyond solar system. Two of our satellites, Voyager 1 and 2, are about 16 billion miles away. So if you have to send a radio signal at 186,000 miles per second, it takes 26 hours to go. And then the acknowledgement comes 26 hours later, and it keeps changing. So our deeper space network system has 3 antenna sets, one in Barstow, California, one in Madrid, Spain, and one in Canberra, Australia. So when the Earth spins, we have each station track the signal for 8 hours, so we have a 24/7 coverage. Because we don't know when when we send the signal, when the acknowledgement is going to come. Why we do this? So when I'm in a plane for a long ride, if my neighbor sitting next to me somehow learn I'm a physicist working for NASA, they always ask, are we alone? Is there life in space? Irrespective of gender, race, ethnicity, religion, skin color, whatever, that's the first question they ask. 10 out of 9 times. Why? Looks like this RV alone is somehow genetically coded into us. It's fascinating. So we can think about that later throughout this presentation. So then why we call solar system, why we are not calling Earth system? For nearly 2 millennia, actually we believe Earth is flat and we are at the center and everything in the universe is spin around us. That's very normal for human beings, for so-called Homo sapiens. Homo in Latin is man, sapien means wise man. That's our genus. So we are very egocentric, less tolerant people. So that's what we think. We put everything around us. So it's normal. So 2 millennia we believed that it was first taught by, in the known history, by aristocrats, the Greek philosopher. Then it was codified by the teaching of Aristotle and Ptolemy, and also preached by the Roman Catholic Church for nearly 2 millennia. And there were some people who thought otherwise. They were put to silence very quickly. For example, in the history, somewhere around late 16th century, the one priest in Italy, Giordano Bruno, came up with the idea, and he started to preach there are other worlds like Earth and the life can exist. And he was quickly arrested, stripped naked, and tied into a pole upside down and burned to death. Aren't you glad that we are living in more tolerant times today? You can tell anything about the universe. You can say it's flat, I don't believe it, it goes around us or not, or it came from Big Bang, but nobody will say anything. They might argue with you, but it won't get physical. So we are in much more tolerant times. I may have to go through my slides quickly. If you have any question, you can stop me later and ask. So this is the outline. I will give a quick introduction to where we are, where I work, and then I will quickly describe the types of spacecraft we use to explore the solar system and beyond. I'll take one example per each satellite class: Voyager, Cassini, Phoenix, and Curiosity. Then I'll talk about the hunting for other planets like us, Earth-like planets in our neighborhood of 100 light years from us. Then we talk about the recent developments and search for life in our solar system and beyond. On this side, this is where I work on the right side, right bottom, as that's the Jet Propulsion Laboratory. It was formed by California Institute of Technology. There's a picture of that on the top left corner. So Caltech is a small university, California Institute of Technology. They formed Jet Propulsion Laboratory in 1936 as a graduate to student experiment. And so it was formed much before NASA, and Jet Propulsion Laboratory gave the first orbiting spacecraft called Explorer 1 to United States in 1958, January 28th. The first two Russian spacecraft, Sputnik 1 and Sputnik 2. So JPL is, we have about 6,500 permanent staff and about 2,500 contractors, so we are close to about 9,000 in a staff. Located about 5 miles away from Pasadena, California, and at the foot of San Gabriel Mountains. And so we all do work for Jet Propulsion Laboratory to explore the solar system and beyond. So on the top left you can see how they started with the 6 graduate students in 1936. Then on the top right you can see in 1940 the JPS first claim to fame was they developed something called a jet-assisted takeoff during the Second World War for planes to take off at very sharp angles. So in enemy territory it helped. It was very helpful. So that's the first claim to fame. Then in 1950 they developed the first guided missile for US Army, and 1958 gave the first orbiting satellite called Explorer. And in Explorer, that time the JPL chief scientist decided to put the Geiger counter, and then he discovered the Van Allen radiation belts around us, which protect us. Actually, if the radiation belt is gone, we are gone too. Because then all the bad radiation coming from the sun and the cosmic rays will bombard us, and pretty quickly the life will be extinct on Earth. So today we have 31 robotic spacecraft, 2 of them beyond the solar system, other 29 around different planets, and 8 major instruments. These are the 4 types of spacecraft we use today. The first one is called a flyby. Sometimes the planets align. So in that case, it's much more cost-effective to send one satellite and observing few planets. So that's a cheaper way to do, but the planets won't align that frequently. And it happened in 1980 time frame. The 4 major planets, Jupiter, Saturn, Uranus, Neptune, they all align. It happens 1 in 176 years. So that's why we developed that technique. The other one on the top right is an orbiter. Orbiting, actually it finished the orbits around Saturn in last year, called a Cassini. On the left bottom you can see a typical lander. This one is a Phoenix lander on Mars. Then on the right bottom you can see a rover. We have 4 rovers on Mars. This one is the largest rover called Curiosity. I'll talk more about that later. So this Voyager is a flyby. We built 2 of them, Voyager 1 and Voyager 2, and launched in 1976 because that time the Jupiter, the largest planet in our solar system, is 1,000 times big as Earth, and it doesn't have a terrestrial land. It's just a gas ball. So if you go to Jupiter and trying to land, going through atmosphere, there's no soil. It has only hydrogen and helium. But the pressure is so high, the inner core is solid hydrogen and solid methane, or we call methane. So, but it has many, many moons. Before we send a Voyager, we knew only 4 moons. Those 4 moons actually discovered by Galileo, called Galilean moons. They're actually bigger than our moon. They're called Ganymede, Callisto, Io, and Europa. When a Voyager 1 went, it found actually, it discovered 54 moons. So the Jupiter has 58 moons. So if you are around Jupiter, you'll always see many, many moons going around it. And so it's fascinating. Not only that, when it went to Jupiter, it looked at one of the Galilean moons, Io, and found big volcanic eruption. This is the first time we observed volcanic eruption beyond Earth. So then it passed through, then we make a quick decision, and it was going to, all these planets in our solar system are on one plane called a solar plane. We quickly make a decision to send this satellite under the belly of Jupiter and deflect it and send it perpendicular. I'll tell you why later. Because we had a second one, which is also in good health. That time we built 2 in case if one goes wrong, but both the second one was coming 2 weeks behind. So it observed the same Jupiter again, and then we send it, let it go straight on the solar plane. Then it went to observe Saturn. Saturn is a majestic planet, serenely beautiful. It has a fantastic ring system. It was first observed by Italian astronomer, and it is also a gas ball, and its density is so low. If you can take this serenely beautiful Saturn and put it on our ocean, it will float. And its rings are made from ice particles. So actually, some ice particles are very small, like sand pebbles, and some are big chunks of ice, could be big as 10 meters. Then also it observed, we knew only few moons of Saturn. It also observed close to about 60 moons. And the biggest moon is Titan. On the right bottom, you can see a picture of Titan, and it has an atmosphere, and the atmosphere is blue. That means it has a primordial soup. It has methane, ethane, that's drinking alcohol, and temperature is very low. It's about 200 minus 200 Celsius, and it's ethane and methane are not gases. They're liquid there. Water is frozen. Actually, this, I'll talk about that more later. We sent a special second satellite to observe that one further called Cassini. So on the middle, you can see another moon of Saturn called Enceladus, which is a very small moon, but it's all covered in ice. It also has a lot of interest because it has rivers, the water rivers, and also hydrocarbons, and probably a primordial soup that's a precursor to life. So this Voyager is very interesting. At that time, Carl Sagan, a professor of Cornell University, he actually encouraged JPL to put a message if there's any intelligent life elsewhere. So we made a copper record, 12-inch record, LP record, and coated with gold, and put greetings from 55 languages, including Ayubowan, that's from Sri Lanka, and 115 pictures, variety of natural sound from birds, whales, and giraffes, lions, and so on. And also that time UN Secretary General Kurt Waldheim's message, and classical and Western music. And also we put a needle and a sign language. If intelligent life capture that one, they'll figure it out how to play that. And also it will tell, we put a sign language where we are, where it came from, so they can point out to our solar system. Not really Earth, but we have a map of solar system, and they know which planet it came from. So it is like a hope. You know, in early days, when people get lost and in ocean and are stranded in some island, they take a bottle and put a message inside and put it into ocean. It's a hope. Somebody will find that. So this is like that. So then when it left the solar system, when it gone beyond Pluto, we turned it around and took a picture of our solar system. That's a black and white picture you see on the right bottom. Because if you are inside the house, you are not allowed to go out. You cannot get a picture of the house. So the same way, this is the only picture of the solar system, because we are inside it. So then landers, just one quick example. This is the first lander we did in 1975 to Mars. Mars got so interested because 1888, Giovanni Schiaparelli, an Italian astronomer, found canals on Mars. He called canali. In English, it's canals. So the Hollywood movie makers hypothesized the Martians and the little man with the big head. So it's complied with the Darwin's theory of evolution. And we believe the Martians are more brainy. Of course, today we know Mars doesn't have intelligent life. There could be a microbial life that we are looking for. We can talk about that more later. So this is a typical lander, and then a Curiosity. Curiosity is the largest rover we built. I have a picture of that here. It's a 2,200 pounds. It's size of a small sport utility vehicle powered by a nuclear power. It's not a real nuclear power generator. We call it it has 77 pounds of plutonium. It generates the heat source. Then it has a thermocouples running to make electricity. It has 10 instruments. It has cameras with very powerful lasers, so it can vaporize rock. Then we can analyze the signal coming from the vapor through spectrometers and find out what kind of minerals it has. It has a chemistry instrument setup. SAM is a sample analysis on Mars. Itself has a 3 inside instrument. I was part of the one instrument called tunable laser spectrometer. Then there's a mass chromatograph and a mass spectrometer. So this one is working on Mars since 2012. And we are building the next one now called Mars 2020. We will launch that in 2020. It will take about 8 months to go there. We launch when the Mars and Earth are close, so then it doesn't have to travel across the solar system. If it has to travel across the solar system, it will take years. But when Mars and Earth get closer every other year, Martian 1 year is 2 Earth years. Mars takes 2 Earth years to go around Sun. So Martian is 2 Earth years. So that means Mars and Earth get closer every other year. Right now, actually, we are the closest to Mars. We are about 100 million miles away. So when we launch it now, we can go there in about 8 months. If we launch something when it is on the other side, it will take like several years to go there, so which is not very economical. So this to explore Mars window comes every other year. So this is a selfie. Selfies are very popular these days. Everybody do selfies. So we also took a selfie of our own rover. Actually, this is a collage of 55 photographs it has taken from its robotic arm. The robotic arm has a camera at the end. So this is where we landed the Curiosity rover called a Gale crater. It's 150 kilometers in diameter. In the middle of that, it has a 5-kilometer high mount or mountain. Why we selected that? From the previous rovers, landers, and orbiters, we have evidence that Mars had running water at some point. It doesn't have running water now. So we know on Earth, the life has started to form as soon as we got water. When solar system, I'll talk about that later, but when a solar system was formed 4.2 billion years ago, our Earth was formed, but it didn't have water. We got water from falling comets. Then few hundred million years later, simple form of life came, formed. So we are looking for life, and life on Earth, we know it's a water base. So we thought if Mars had running water, this huge crater should have some water. So we landed this one right here. Actually, we land it on the circle here. Well, I couldn't get back to that one. Oh. Okay. So this is just artistic rendering. You see a blue patch. That's where we think water was. So it probably had the rivers carrying water to that big lake. So we want to explore that riverbed. So this is a picture taken when it was going through the Martian atmosphere and slowing down by a huge parachute. And it was taken by one of our orbiters called Mars Reconnaissance Orbiter, orbiting around Mars since 2005. We have 11 assets around Mars, some orbiters, 4 rovers, and some one lander, one fixed-legged lander. So this is a picture taken by its cameras during landing. And the below is the rover. On top of that, we call a sky crane or jetpack. Actually, it is holding the rover by 3 cables. And so when it detaches the 3 cables, and then the jetpack or the sky crane goes away and falls somewhere else. So its job is done. So you can also see the jets coming. Those are actually liquid hydrogen burning. Then you can see the storm underneath the jetpacks. Actually, it's blowing off dust. Now, this is once everything finished, actually it was blown about 4 feet of dust and burned the rock underneath. So then it started to move, and this is one of the first pictures we have seen. If you see this kind of picture on Earth, what do you think? It's probably from a river bed, right? Why? Because these pebbles don't have a jagged edges. They are smooth. If you go to a riverbed and take the stones, or even from a creek, they're all circular. Why? Because millions of years they roll, they grind and roll, so it becomes spherical. So this is a clear evidence Mars had running water. And when we take the dating, it looks like this happened about 100 to 200 million years ago. So 100 to 200 million years ago, Mars had running water. This is another picture. You can see spherical rocks. So then this is the sand. When you analyze the sand, these are very fine sand, an enlarged picture. Even the sand look spherical. That means it definitely had running water. Then we analyze various other things. On the right side, you see a Martian rock called a vein rock or sheep bed rock. On the right side, you see the same rock on Earth. And in these veins, they are white, and they're actually calcium carbonate and calcium sulfate. When the water carries, it mixes with calcium and sulfate, it deposits in the cracks. So we see the same thing on Mars. So there are much more evidence. We took samples. In the sample analysis chamber, we heated them to 1,000 degrees and observed what's coming out. We got water vapor, oxygen, sulfur dioxide, carbon dioxide, other carbonates. And so this is another picture of a canyon wall of Mars. This happened only in the summertime. In summertime, we start to see these dark lines. So we analyze them. So what happened is the ice melt. Mars has ice, a lot of frozen ice called a permafrost. It's a mud, frozen mud, like in northern Canada. So in the summertime, it melts and the water starts to seep through the banks. So we couldn't find liquid water on Mars because the Martian pressure is 1% of Earth pressure. 96% of the atmosphere is carbon dioxide, some water vapor, a little bit of oxygen. So it had running water. What happened to it? So actually, we have a theory. To confirm that, we just launched 3 months ago the InSight spacecraft. It's a fixed-legged lander. It's going to land on Mars in about 5 months. Then it's going to investigate the Martian core by seismic and also measuring temperature. We think, in Earth, the center is a lava ball. It's molten rock and minerals and going around. And we are on the crust, which is in the thickest part 18 miles. In the thinnest could be near volcanoes, it's about 2,000 feet. So we are on the crust. So our magma ball going around 5,000 degrees, and its ions ripped apart, and there's a most ionized, the electron rip apart. So it's a current. This current is a dynamo. It generates our magnetic field. And that magnetic field protects us from the solar wind coming, the dangerous particle ions coming from sun and other cosmic rays. That's the Van Allen belts. Our satellite has to go through that all the time. So that protects us from the radiation, so we are sort of safe. Ozone protects us from UV, so it's conducive to life. So in Mars, what we think, what happened, we don't know. From inside we can confirm that. The Mars scientists think the inner core of Mars had volcanoes and everything in the past. So the core get colder, and it becomes solid. We call a dead planet. So Mercury, the very first planet after the sun, the Mercury, Venus, Earth, Mars, also a dead planet. Its core is dead. When the core is dead, nothing is moving, so no current, no magnetic field. So now what happened, the high energy solar wind coming from sun in supersonic speed hit the atmosphere. And it's like sand blasting. If you take a car and blast with sand, what happened? Its paint is gone. So on Mars, this thing hitting in supersonic speed, Mars is 1/3 of the size of the Earth, so the gravity is 1/3 of the Earth. If you can jump 1 foot here, up. If you jump the same thing in Mars, you go 3 foot up. On Moon, you go 6 feet up because the gravity is 1/6 of Earth. So the gravity is 1/3, so the gravity, less gravity, so it's hard to hold the atmosphere. Now the solar wind is blasting, so the atmosphere got eroded. It just went into space. And even today we know atmosphere is eroding. When the atmosphere eroding, less atmosphere, that means a pressure drop. For everything has 3 phases, solid, liquid, and a gas. So all the gas is gone, then the liquid water, the pressure drop, it vaporized. And it's also left. Whatever frozen as a mud is there because Mars is much cooler. And a good summer day, Martian temperature is about 0 Celsius. In nighttime, -100 Celsius. Because it's very thin atmosphere, it cannot hold. Our thick atmosphere make it very warm. I mean, it's like a blanket. It keeps the heat. So, and also the water, the body of water in ocean. So that's what happened to Mars, we think. If you leave a glass of water on Mars, it cannot support. It just vaporizes. So then it goes to atmosphere, then it leaves because of blasting by solar wind and a small gravity. So we want to find out what happened to Mars. Can it be happen to us too one day? Hopefully. The Homo sapiens may be not living that time. So this is an example of an orbiter, a Cassini orbiter. This is the largest orbiter actually human beings launch beyond Earth. This is a 13,000 pound orbiter we launched in 1997. It took 7 years to go to Saturn. We actually launched it towards the Venus to get a gravity pull, and came to Earth, took a gravity pull, went to Jupiter, took a gravity pull, and went to Saturn because we didn't have a large enough rocket to launch from Earth directly to Saturn. So we used a gravity assistant from other planets. So when it went to Saturn, it took actually a probe given to us by Italian space agency called a Huygens probe. It dropped onto the Titan. Titan is its largest moon, and a Voyager observed a hydrocarbon atmosphere. So it went down and took the pictures you are seeing on the middle and top middle and top right, and you can see some rivers, lakes, and actually these rivers and lakes have not water, liquid ethane and liquid methane. So it's quite interesting. It actually interacts. It has a very thick atmosphere, also methane and ethane rich, and interact. It has a cloud deck. Like on Earth, our rain cycle, water cycle interact with soil. It vaporizes, clouds, then rain, then it erode the land and take it through the rivers to ocean and goes in. So it's happening on Titan. So we are very much interested in sending a very specific satellite just to Titan to explore the possibility of life there. So then it comes to the small Enceladus. Until Cassini, we didn't know Enceladus has rivers. In the middle picture, you see the blue lines? Those are actually rivers. But we didn't know, so we sent the Cassini 5 miles above its surface. So it was a very risky maneuver we did, Then we found it has a geysers called jets. Actually, these jets are emanating on the top left bottom. You can see what we found. It has water, hydrocarbons, carbon dioxide, carbon monoxide, and everything that a primordial soup needs. Now we know 4 places that has water in our solar system. Mars, Europa, which was the icy moon of Jupiter, Titan, and Enceladus. So we want to investigate all 4. So we encourage NASA to fund. So actually NASA just last year funded the Europa Clipper mission. Europa is one of the large moons of Jupiter, which Galileo discovered. And from the previous one of our satellite called Galileo around Jupiter found its crust is ice, and that ice crust is cracking all the time. Cracks develop. We didn't know first why it is happening, and we thought about it. You know, on Earth, when the moon comes above us, it pulls the Earth crust about 6 centimeters up. On water, it pulls even more. So we get a high tide and a low tide. So we knew how to manipulate the shipping and everything, the high tide, low tide. So navies knew that, how to do that, use that to advantage. So the same thing is happening in the Jupiter system. It has 4 big moons. So above Europa, there's a Ganymede and Callisto, even bigger. When they go above that, like a heart, it swells. When it passes, it goes down, shrink. And so it's like this. So the ice crust, ice cracks because it's so cold, it has water, the top is ice, it cracks, then it goes down. When it's happening, the crust, the crack, actually grind against each other. So that become mechanical energy, become heat, and that heat makes ice water. So we are sending, we actually start to build a satellite called the Europa Clipper to send to Europa probably around 2024 time frame, and we want to find out if it has water, whether it has life. But around Jupiter, it has a big planet, the magnetic field is very strong, the radiation belt is extremely tough. So it's extremely hard for us to keep electronics, and they get all kind of burned with the high radiation levels. So search for planets. Until about 20 years ago, the planets around other stars, all the heavenly bodies we see are stars. They're like our sun. Some are much bigger than our sun, some are very small. So this is the whole range. We call the top one the giant planets, the medium-sized giant stars. The medium-sized stars is like our sun. Then there are dwarf ones, very small. So very hard to see. So around them, there should be planets like our thing, right? Our solar system. But it's very hard to see because a star is so bright. So it's very hard to see. So it is like in United States, there's a saying, if you take a Boston on one end, other end in San Diego, they are about 3,500 miles away. So if you observe in Boston with a flashlight, naked eye observer, and there's a flashlight in San Diego, and there are bugs going around the light, a moth. So if one observer has to find those moths 3,500 miles away going around a flashlight, it's very difficult. Because if you look at the light, dust particle going around light, you can see because the light is so bright. So we developed techniques, 4 techniques, I'm not going into details, to find these planets. The bigger the planet is easier to find, the smaller is difficult. Because these planets can harbor the life, not the star. Star is so hot anyway. That's like 5,000 degrees, so life cannot survive. Then if we find planets, the planet has to have water, of course, to harbor life, that's what we think. Then why I can explain later. Then it has to be in a certain region of that solar system, around that star. It's called a Goldilocks zone. If it is too close, too hot, water is vaporized. Because we have to go to Venus, temperature of Venus is 650 Celsius. Water is all vapor. It's not conducive to life. If we go further, water is frozen unless there's some kind of a heating mechanism. So we are in the right sweet spot. So the water is liquid. So it's very conducive to life. So it's one of the ideal places. So 2009, we launched the Kepler telescope to find these planets called exoplanets orbiting around stars in the neighborhood of 100 light years from us. And so far, it has found about 5,000 planets orbiting around our neighboring stars. The closest is about 39. One is 39.5 light years away. The other one is about 15 light years away. And out of 3,500, we found only 2 planets, Earth-like planets, and one we think there's water. But on the other hand, we shouldn't get discouraged, because look at our galaxy, Milky Way, has about 250 billion stars. Then, so far we have discovered about another 250 billion galaxies. So 250 billion times 250 billion, so many stars. Then if each star has a 10 planet, there are so many planets than all the words uttered by human beings in last several million years. So there's an equation called Drake equation. You can put the numbers. The last time I put, there's about probably 100,000 planets in our solar system that can probably harbor life. So then now we are building a lot of big telescope, a space and ground-based telescope. This slide shows that. On the top left, you see then the next generation of space telescope called a James Webb Space Telescope. It was supposed to finish 15 years ago, but it has a lot of technical issues. It's Hubble telescope, you all heard, it has a 2-meter mirror. This has a 6-meter mirror. So this is much larger, and hopefully we can launch that in about 3 years or so. Then on the left bottom, you can see a big telescope called a Giant Magellan Telescope. Several universities are building in Atacama Desert in Chile. This has 7 mirrors, so the total width of the mirror is 25 meters. The current largest is a 10-meter telescope, the Keck telescope in Hawaii, in the Mount Mauna Kea. So on the right side is a Caltech proposed the next TMT. There's a 30-meter telescope to be built on Mount Mauna Kea within next 5 years or so. So with these large telescopes and space telescopes, we think we can find life elsewhere, actually within our neighborhood, within 100 light years from us, hopefully in near future. When we're looking for life, we are looking for life around the Earth-like planet hovering around medium-sized stars like us. Why? The bigger planets, bigger stars, like giant red stars, their lifetime is very small. Even though they are giant, their burn rate is very high. In 200 million years ago, it's gone. It exploded by supernova. Then medium-sized stars like us survive about 10 billion years. So that gives plenty of time for life to evolve. The biological process is very lengthy. It won't happen tomorrow unless we do it artificially. That I'll talk about in a minute. So the smaller ones, we don't care. We call them non-sequence 1 stars. In a stargate, most of the stars get energy by a fusion reaction. Most of the matter in the universe is hydrogen. The stars are mostly hydrogen. So the gravity is so high, the 2 hydrogen nuclei brush against each other and form helium, as called a fusion reaction. It generates the heat, it ignites the star. So the smaller ones doesn't have enough gravity to initiate that. So they are only plasma balls, they are glowing. They cannot provide enough heat to the planets, if there are planets. So if there's water on those planets hovering around a smaller star, they may be frozen. So we are not interested. So we want to find Earth-like blue planets, blue because of water, hovering around medium-sized stars like our sun. So there's have a potential to have life. So this is one, called a TRAPPIST one we found last year. That's a small sequence one, a star 39 light years away from us, has 7 planets, most have water and conducive to life. So that's the best. So the building blocks of life. So the building blocks of life is carbon and hydrogen. The CH plus ion. So there are plenty of those in the universe. We found from NASA Spitzer telescope we developed about 20 years ago. It's still in space. Then on the left bottom, you can see those long molecules. They are called polycyclic achromatic carbon. They're made from CH plus ions. They are the building blocks of life. They are in hemoglobin. And there are plenty of them around. Why? Because our universe, if you take the abundance, 92% are hydrogen. 7.1% of the material in the universe is helium, which is not interacting, so inert, so we don't care about it. Then the next is oxygen, then the next is carbon, and so on. So those are the molecules we have in the abundance. So the life has to be around them. That means carbon and water-based life. So if the life is formed by molybdenum, tantalum, and plutonium, then it is very awkward because they are not in quantity. They're very, very little in the universe, very little, and even very hard to form. They form only from neutron star collisions, and so the life cannot exist. But that's why we are looking for water-based life and a carbon-based life. And the life can come in surprises. Look at the life on Earth. Take the algae, the bacteria, a lion, a bird, a jellyfish, and a human, and a giant tree. Look, and a snake. See how things are varying. So nothing much common except carbon, hydrogen, and oxygen, and nitrogen bonds. So think about, you have to explain a snake to one of the person you meet from another planet. How do you explain? The person from other planet never seen a snake because there's no snake. Now you have to explain. You think, you got to believe this. We have this animal like a rod. It has no hands, no legs. It has 2 infrared sensors to hunt its prey. It can swallow its prey 5 times big as his head. My head is this, so now the guy is thinking, head, he swallow this kind of thing, how the hell that happened? Can slither, I take the word slither out because no snake, so he doesn't know slithering, can move 2 feet per second. It can kill a person like me in a couple of hours by biting and injecting some proteins allergic to us. So how is that? So when we look for life, it don't have to be our shape or anything. It could come in different forms. But it got to be water-based, it got to be carbon-based. So that's a life we are looking for around us in solar system and beyond. So just to summarize how we came to be. Actually, 12.6 billion years ago, there was nothing. Then there was energy that was in a very small place. It exploded, the so-called Big Bang. When it exploded, it released energy. Then it started to cool down, then it formed the building blocks of matter, the quarks. It produced electron and hydrogen. then it forms obviously helium. That's why so much of, hydrogen, the very first element, atomic number 1. So that's why we had so much of hydrogen. Then the first sequence of stars were hydrogen burning. Hydrogen became helium. No other periodic table, no life, of course, no carbon, no oxygen. So then these stars, toward the end of its life, ran out of hydrogen, and then the 2 helium start to coalesce and make boron, beryllium. Then hydrogen and helium coalesce because not enough hydrogen, make lithium. And in the explosion of these stars at the death process, form the periodic table. So our star was formed, there was a previous star, first generation. From its explosion, make the solar nebula, the dust cloud. From that, form our star, sun, with the periodic table. So that gave the life to us. Then made the solar system. So the study of matter, the energy, and the space and the time is called physics. That came 12.6 billion years later. Then about 500 million years later, these atoms start to form molecules. So the study of molecules and a reaction of these molecules became chemistry. Then 4.2 billion years ago, our solar system formed. Then we got water 500 million years later from falling comets. Comets are the icy bodies from far away between our star and the other stars called the Oort cloud. The icy bodies, when they fall, capture into our gravity, it brought the water. Then within another few 100 million years later, these molecules joined together to make larger structures, the so-called organism. And that's the life. Study of that is a biology. Then the life forms created, formed, and those extinct due to various things. That's another subject. Life can extinct due to various things. We know at least, it's a proven 65 million years ago, we were hit by a 7-mile long or diameter big asteroid in Yucatan Peninsula in Mexico. And it wiped off all the life. How? Because it's only in that region, but it put so much dust into the upper atmosphere. The atmosphere carried the dust. It blocked the sunlight. So it's of the rain cycle. Plants died, dinosaurs died, everything died. And how we found, whenever we find, then the dust settled 200 years later, again life came out. It gave a chance for the life again. If we find a dinosaur bone in Soviet Russia, just before that there's about centimeter or so dust, and that came only from Yucatan. That's why we know it came from Yucatan. So then probably life came and extinct again. Somewhere about 6 to 7 million years ago, a great ape gave birth to 2 sisters. One sister became a great-grandmother of chimpanzee. The other became the great-grandmother of ours. Then, about 2.5 million years ago, the genus called Homo, like the family, the canine, there's a family, right? Dog, wolves, jackal, foxes, they're in one family, jackal. The feline is a lion, tiger, leopard, mountain lion, panther, and a cat. So our family is a Homo, the man family. Man family came around 2.5 million years ago. That's a chimpanzee, gorilla, orangutan, and the man, us, the Homos. Then there were various kind of Homos, not Homo sapien, the Homo erectus, Homo denisovans, Homo neanderthals, and various. And then about 150,000 years ago in Eastern Africa, the wise man, so-called, we call ourselves wise man, Homo sapiens. They were very aggressive. They spread all around the world. We don't know how, but that's the job the biologists, anthropobiologists trying to figure it out, how the other Homo families get extinct, we don't know. Maybe we got rid of them or they couldn't survive. But today they are no longer there. But our DNA has about 1 to 4% Neanderthal. So there may be some crossbreeding, we don't know. So then, somewhere around 70,000 years ago, a revolution happened called, so in cognitive revolution, somehow we got the logic into our brain. You know, our brain is pretty big. If you take a 150-pound animal, the brain volume is 12 inch. In 70,000 years ago, our brain was about 36 cubic inches. Today it's about 75 to 85 cubic inches. We have proportionally high brain. Of course, we pay a big penalty. To keep the brain, even when we are sleeping, we need 25% of the body energy. We need a lot of energy. But that gave the thinking power, so we developed, cognitive things. So logic and various things. So that's the first revolution. Then somewhere around 12,000 years ago, the agricultural revolution with the warming and so on. The ice age was gone, so the civilization. Now 500 years later, 500 years ago, we started the scientific revolution. So today, we do various things. Our ancestors, probably 2.5 million years ago, never thought we'll walk on moon. We escaped the gravity of Earth. We became the second kind of a species, not the first generation. Now we have a presence even beyond solar system. Look at what's happening. We fathomed the genetical code now. The scientists making new life. Like a couple of years ago, the French scientists, many scientists create life in various places. They made the artificial rabbit. They took the glowing fluorescence of a jellyfish and mixed and made the glowing rabbit. A fluorescent rabbit or glowing rabbit or luminescent rabbit. Now the Homo sapiens creating life. We were destroying life for sure, but we didn't have the ability to create. Now we are creating life. So what we are going to be? Many cultures and societies, especially Western and some Eastern too, we thought only the God can create life. So what? Homo sapiens going to play a role of God too? Question for you. Thank you for your attention. I hope you enjoy. Thank you.
Thank you, sir, for sharing with us those wonderful details. Ladies and gentlemen, we have here with us today two extraordinary individuals whom I may call brilliant scholars, scientists and thinkers. In recognition of their invaluable contribution to their respective fields of study, today KDU will award them honorary professorships. I would now like to invite Senior Professor Susirik Mendis to read out the first citation.
Chief guest, Chancellor, Vice Chancellor, Excellencies, distinguished invitees, ladies and gentlemen. It is a distinct honor and privilege for me to stand before this august assembly to introduce once again Professor Mohan Munasinghe, a world-renowned visionary and scientist who has brought great honor to his motherland, Sri Lanka. To reiterate, Professor Mohan Munasinghe is a multifaceted scientist, an academic, and an intellectual. Having earned his BA and MA degrees in engineering from Cambridge University, UK, and professional degrees in electrical engineering from the Massachusetts Institute of Technology, USA, he then changed tracks a bit into physics to read for and earn a PhD degree in solid-state physics from McGill University, Canada. Not satisfied with the pure and applied sciences, he went on to the social sciences to obtain a MA degree in development economics from Concordia University, Canada. In that sense, Professor Mohan Munasinghe is a modern-day Renaissance man, a polymath in the great traditions of creative human endeavor, as was the incomparable Leonardo da Vinci. It was a result of this comprehensive universality of knowledge that he had accumulated in different fields of academic pursuit that he was entrusted with the onerous responsibility of the Vice Chair of the UN Intergovernmental Panel on Climate Change. The immense path-breaking work he did there was instrumental in him being jointly awarded the Nobel Prize for Peace in 2007, and thereby becoming the first and up to now the only Sri Lankan Nobel laureate. In recognition of the global reach of his contributions, the President of France bestowed on him the highest French decoration, Officer of the National Order of the Legion of Honor. Professor Munasinghe is the author of over 100 scholarly books and about 300 technical papers in high-quality indexed scientific journals on climate change, disasters, environment, sustainable development, energy, transport, urban infrastructure, water resources, telecommunications, and sustainable consumption and production. The vast scope of his intellectual endeavors is phenomenal, the proof of which you have seen in the keynote address today. Today he is recognized as a leading world authority on sustainable development, energy, and protection of the Earth's fragile environment. His research and applications have contributed to two major international achievements: the UN Sustainable Development Goals and the Paris Agreement on Climate Change. Professor Mohan Munasinghe has served as advisor to the US President's Council on Environmental Quality and a myriad of international organizations that include the UN, UNDP, UNESCO, ESCAP, USAID, CEDA, IDRC, European Community, IAEA, ADB, and the IDB. But he has not failed to give of his expertise, knowledge, and intellect to also serve his motherland, Sri Lanka. He has served as the senior advisor on energy and information technology to the President of Sri Lanka and was a member of the Presidential Commission that determined national telecommunication policy and the projected 2030 plan for Sri Lanka. He has served as well in many other scientific institutions in Sri Lanka that include SINTEC and NARESA, now the NSF, and as the governor, Arthur C. Clarke Center for Modern Technology. He has received many awards from highly prestigious national and international organizations and institutions from all continents of the world. That is too numerous to list here today, but a few of them need specific mention. They include the top World Energy Award from the Energy Global Foundation in Vienna for outstanding work on energy, sustainable development, and climate change. The Excellence Award from the UNDP Administrator for outstanding contribution to sustainable, inclusive, and resilient development, and assisting the UNDP to build empowered lives and resilient nations. The Green Cross International Award for outstanding contributions to global sustainable development and environmental protection. The prestigious Anita Garibaldi Gold Medal for meritorious service to humanity from the Brazilian government. and the Adelman Frankel Prize for unique and innovative contributions to energy research by the U.S. Association of Energy Economics and the International Association of Energy Economics. It is hoped that Sri Lankan scientists will be greatly encouraged to emulate him and aspire to reach the magnificent heights that Professor Mohan Munasinghe has reached and kept. To paraphrase the great English bard Henry Wadsworth Longfellow, these great achievements were not attained by sudden flight. He, while his companions slept, was toiling upwards in the night. Chancellor Sir, it is with great pleasure that I present to you Professor Mohan Munasinghe and invite you to award the honorary professorship of the General Sir John Kothawala Defence University to Professor Mohan Munasinghe.
I would now like to invite Dr. Dashanti Silva to read out the second citation.
Excellencies, ladies and gentlemen, it is a great pleasure to stand before this assembly to introduce Dr. Sarath Deshapriya Gunapal, a visionary and a world-renowned scientist who has brought great honor to his motherland, Sri Lanka. A senior scientist, a solid-state physicist, he is currently the director of the Center for Infrared Sensors, NASA's renowned Jet Propulsion Laboratory, managed as part of the famous California Institute of Technology, also known as Caltech, in Pasadena, California, USA. The Jet Propulsion Laboratory is a research facility that carries out robotic, space, and earth science missions as its main function. As highlighted in the video, Dr. Gunapala, born in Sri Lanka, educated at Nalanda College, later graduated from the University of Ceylon. Then he completed his MSc and doctorate in 1986 on infrared photoionization in semiconductors with Professor D.D. Kuhn at the University of Pittsburgh. Following his PhD, he carried out his postdoctoral work at the famed AT&T Bell Laboratories in New Jersey, USA. These labs established by Mr. Alexander Graham Bell, who invented the telephone. Following his stint at the AT&T Laboratories, he joined the NASA Jet Propulsion Laboratory from 1992 and has remained there to this day. You have heard a lot about the Jet Propulsion Laboratory. I won't elaborate. As highlighted in the video, his research in infrared imaging has been applied to enhancing night vision, medical diagnostics, service, and maintenance applications, as well as earth and planetary science remote sensing applications. He is currently the principal investigator of a major US Department of Defense funded infrared detector program at JPL, in addition to an industry consortium formed between JPL and several major US industries. He has over 110 publications in international refereed journals, 25 patents, 75 new technology reports, and been involved in writing 13 book chapters. He has numerous awards. I will cite a few: the NASA Outstanding Leadership Medal, NASA Exceptional Engineering Achievement Medal, NASA Space Act Award for Exceptional Performance, Career Achievement Award, inducted to the United States Space Technology Hall of Fame in 2001. Then in 2011, he received the NASA Jet Propulsion Laboratories Magellan Award for leadership in the development of technology for high-performance infrared focal planes for space exploration. In addition, he has an award from the US Army, RDCOM CERDEC. He's an IEEE Distinguished Lecturer Award and IEEE Aaron Kressel Award. In Sri Lanka, he has received the Sri Lanka Ranjana Presidential Honours and the Kirti Sri Felicitation from Nalantapalli. Chancellor Sir, I have the honour to present to you Dr. Sarath Deshapriya Gunapala for the appointment of Honorary Professor at General Sir John Kothawala Defence University in recognition of his vast contribution to the advancement of science.
Thank you, sir. Ladies and gentlemen, there are many who joined hands with utmost commitment to make KDU IRC 2018 a success. And it is important to acknowledge all such efforts taken. This invitation is therefore extended to Dr. Bali Rajapaksha, the Conference Chair of KDU IRC 2018, to deliver the vote of thanks.
Honorable Secretary to the Ministry of Defence, Mr. Kapilava International, Professor Mohan Singha, Dr. Sarath Gunapala, now Professor Sarath Gunapala, and distinguished guests. Good morning to all of you. To KDU, today is a long day, and also it is a red letter day for us. Such an important day. This important day was brought by many people with their valuable contribution. Hence, I am here to share my sincere thanks with them. KDU usually start IRC in the month of January in each year and hold the conference in the month of August after 8-month duration. This year, we started month of April and had the conference in month of September after 5 months. It's a challengeable target. But I have a very good team with that. With them, it's not a big challenge. And so many people contributed to us and they deserve the thanks from us. Firstly, on behalf of KDU, I extend my heartfelt thanks to our Chief Guest, Honorable Secretary to the Minister of Defence, Mr. Kapilava International. And it's my great pleasure to acknowledge our gratitude to Professor Mohan Singha and Dr. Sarath Gunapala for sharing with us their findings and opinions. My sincere thanks goes to our Vice Chancellor, Deputy Vice Chancellor, Defence and Administration, Deputy Vice Chancellor, Academic for their consistent guidance and throughout this journey. Further, my special thanks goes to our sponsors, Ministry of Science and Technology, Ministry of Telecommunication and Digital Infrastructure, Bank of Shillong, and our suppliers. Further, my secretaries, my coordinators, editors, committee presidents and the members, registrar, adjutant, CEO, SO1, your contribution is greatly appreciated. My sincere thanks goes to, again, Mr. Kitsi Ramaratunga, the President of Editing Committee, Dr. Premdas, former IRC Chair, and the Dean of the Faculties. I thank to all who supported me in multiple ways in order to make this event. Finally, I would like to make a personal thank to Vice Chancellor and Dr. Namali for selecting me as the chair for the 2008. Thank you, sir. Thank you, madam. Ladies and gentlemen, we thank you for being with us this morning. Have an inspirational and fruitful day.
Thank you. Ladies and gentlemen, with that we come to the closure of the inauguration ceremony of the 11th International Research Conference of General Sir John Kothalavala Defence University. Before we disperse, there are a few important announcements to be made. First of all, I would like to request the pre-informed invitees to remain in the auditorium for a moment for the conference photographs. You will be directed to the stage by appointed usherers. Secondly, refreshments have been arranged for all guests, and I would like to request all invitees whose name tag lineas are color-coded in red to proceed to the first floor for refreshments, and those with blue lineas to proceed to the third floor. All the other invitees are requested to proceed to the second floor. And lastly, and most importantly, following the tea, we would hope to see you again at this location in 15 minutes time. I think that would be around 12:05 for the defense plenary session. Thank you and have a good day.